Good day, engineers. I am ZJEANRO Angelo, and I am going to discuss to you the center of symmetry, rotoinversion, and the quartz family. I hope you enjoy the entire video.
Good day everyone. For our topic this time would be the center of symmetry, rotoinversion, and quartz family. For our first topic would be the center of symmetry. A center of symmetry exists in a crystal if an imaginary line can be extended from any point on its surface through its center and a similar point is present along the line equidistant from the center. At this time, I am going to introduce to you the four symmetric elements that are expressed in crystal morphology, and these are the six-fold axis of rotation, four-fold axis of inversion, the center of symmetry, and the mirror plane or the symmetry plane. Under the center of symmetry, the illustration is expressed in crystal morphology, and this is called the six-fold axis of rotation. It is a single line called an axis of six-fold symmetry about which the cell can be rotated by either 60 degree or 120 degree without changing its appearance. Also, if rotation of 60 degree about an axis causes the object to repeat itself, then it is also called a six-fold axis of rotational symmetry, and this is mathematically expressed in 360 over 60 equals 6. So the illustration is a filled hexagon that is used as a symbol for six-fold rotation axis. So for our next element would be the four-fold axis of inversion. Four-fold axis of inversion involves rotation of the object by 90 degree, then inverting through a center. A four-fold rotoinversion axis is symbolized as a diamond with a line in between. The illustration have the two faces on the top and two identical faces upside down on the bottom if the axis is held in the vertical position. As we can see on the illustration below, we can differentiate the plane of projection between the two, the 10 four-fold rotation from the left and the four-fold inversion from the right, in which the 10 four-fold rotation involves rotation more than 90 degree. It is represented by a black diamond. However, the four-fold of inversion rotates only by 90 degree, that's why we can only see a single black line between the diamond. And so for our third one, we have the center of symmetry. A center of symmetry is an imaginary point in the molecule such that if a line is drawn from any group of the molecule to this point and then extended to an equal distance beyond the point, it meets the mirror images of the original group. Center of symmetry is also called the center of inversion. Also, a center of symmetry is equivalent to a single fold of rotoinversion. So I use dimethylcyclobutane and dicarboxylic acid as an example because it explains how a center of symmetry being formed and occur in a system. So for the last free symmetry that is expressed in crystal morphology in a center of symmetry would be the mirror plane or the symmetry plane. A mirror plane is an imaginary plane that divides the crystal into mirrored halves. So as we can see on the illustration, the crystal is being divided by a red or pink color, which means the left side and the right side have an equal size, shape, and properties. To have a closer view, a mirror plane is an operation of reflection that is carried out with respect to a symmetry element, in which we give the symbol of sigma. The best example for this mirror plane would be the butterfly. This type of symmetry is also called a bilateral. The left half of the butterfly is equivalent to the right half. So it means the mirror plane or the sigma is perpendicular to the page and bisect the butterfly as indicated by the dotted line. Let's proceed to the next topic, and it is the rotoinversion. A rotoinversion is a combination of rotations with a center of symmetry perform the symmetry operation of rotoinversion. And objects that have rotoinversion symmetry have an element of symmetry called a rotoinversion axis. A one-fold rotoinversion axis is the same as a center of symmetry. And there are other possible rotoinversion are as follows: the two-fold rotoinversion, the three-fold rotoinversion, the four-fold rotoinversion, and the six-fold rotoinversion. So for the two-fold rotoinversion, it is the operation of a two-fold rotoinversion that involves first rotating the object by 180 degrees, then inverting it through an inversion center. This operation is equivalent to having a mirror plane perpendicular to the two-fold rotoinversion axis. A two-fold rotoinversion axis is symbolized as a 2 with a bar over the top, and it is being pronounced as bar 2, but since this is equivalent of a mirror plane M, the bar 2 is rarely used. From the illustration, we can easily determine of what kind of rotoinversion it is because it is the same with a mirror plane. So the three-fold rotoinversion involves rotating the object by 120 degrees and inverting through a center. A three-fold rotoinversion axis is denoted as bar 3, and note that there are actually 4 axes in a cube, one running through each of the corners of the cube. If one holds of the axis vertical, then note that there are 3 faces on the top and 3 identical faces upside down on the bottom that are offset from the top faces by 120 degrees. So from the illustration, we have a cube. It is a good example of an object that possesses the three-fold rotoinversion axis. The next one is the four-fold rotoinversion. It involves rotation of the object by 90 degrees, then inverting through a center. A four-fold rotoinversion axis is symbolized as bar 4. Note that an object possessing a four-fold rotoinversion axis will have 2 faces on the top and 2 identical faces upside down on the bottom, if the axis is held in the vertical position. So the illustration is clearly defined the fourfold of rotoinversion and how it looks like. So for the last topic for the rotoinversion will be the six-fold rotoinversion. A six-fold rotoinversion axis is symbolized by bar 6 that involves rotating the object by 60 degrees and inverting through a center. Note that this operation is identical to having the combination of a three-fold rotation axis perpendicular to a mirror plane. The illustration of a six-fold rotoinversion is somehow similar to the cube of a three-fold rotoinversion axis. They just differ in functions. And so for the last topic of my report would be the quartz family. Quartz family is composed of silicon and oxygen, and when it combined, it is called a silicon dioxide. Quartz is the second most bountiful mineral found in Earth's crust, that is being discovered in Alps mountain range in Europe, and was believed to be a form of frozen water and therefore called crystals. Quartz comes in a vast array of colors and shapes, when crystals and the cryptocrystalline varieties offer an almost endless spectrum of color and patterns. Quartz or silicon dioxide can be divided into 2 major categories, and these are the macrocrystalline varieties and the microcrystalline varieties, or also called the cryptocrystalline. So I'm just gonna show you the examples of quartz family under the macrocrystalline and the microcrystalline or the cryptocrystalline. Macrocrystalline, we have rock crystal, amethyst, brown quartz, yellow quartz, rose quartz, milky quartz, and amethyst citrine. And for the cryptocrystalline, we have 5: the chalcedony, agate, the carnelian, onyx, and jasper. Thank you for watching, guys. I'm Angelo ZJEANRO, studied Geology for Engineers under BCE 221, code 3391 from Group 2 Olu2A.
Thank you for watching, guys, my entire video. I hope you enjoy it, and Keep learning, embrace new experiences, because learning never ends. Thank you.